Good day, everybody. It's Demon Storm 666 here. Now, in our last episode, we actually looked at the formation of galaxies and how they formed out of the crucible of the Big Bang and that fiery hot soup that was the state of the universe for such a long period of time. Today, we're going to be taking a look at how stars form. Basically, you have to imagine a large cloud of gas and dust. Now, if a gas cloud is massive enough that the pressure of the gas in that cloud is insufficient to support it, then the cloud will undergo gravitational collapse. Now, in order for a star to form, that collapse needs to increase in density. There are two ways that this can happen. It will either collide with another dense cloud of gas, or it could be near enough to a supernova that the pressure caused by the supernova adds to its density. Also, there is another way stars form, but it's not as common. Many stars can be created at the same time when two galaxies collide with one another. And this is due to the massive pressures that are created by such an event. So when two galaxies collide, many stars are born at the same time because of that event. But anyway, in any case, heat is needed to fuel this reaction, which comes from gravity pulling inwards at all the material that is going to make up that star. Now, depending on the size of this protostar, one of several things can occur. Now, if the protostar is small, it doesn't have enough energy to become anything but a brown dwarf star. A brown dwarf is basically a failed star. You could look at it as a much bigger version of Jupiter, and brown dwarfs are also known as substellar objects. It can't maintain the large temperatures that are required for fusion. Now, only a few brown dwarfs can actually be called stars as such, and this depends mainly on their chemical composition. Eventually, however, over billions of years, a brown dwarf will cool to become the same temperature as the background temperature of the universe, so it basically dies a slow, quiet death. Now, medium or large protostars can take one of two paths depending on their size. If they are smaller than our own Sun, they undergo a chain reaction which leads to the fusion of hydrogen into helium. If they are larger than our Sun, they undergo a carbon-nitrogen-oxygen chain reaction, but the end result is the same, fusion of hydrogen into helium. The difference is that the latter method requires much higher temperatures than the former method. Now, whichever path is taken, or whichever path a star follows, a new star is born out of this process. Now, the life cycle of a star depends on how quickly it consumes the fuel within it, the hydrogen. A red dwarf star can last hundreds of billions of years, while large supergiants can burn through most of their fuel within a comparatively short million years or so. But once a star has consumed most of its hydrogen fuel, it has reached what we call the mature state. Now, the clouds of gas that stars are born in are probably amongst the most spectacular stellar phenomena in the universe, and they're called nebula. What you're looking at the moment is the Eagle Nebula, and the Eagle Nebula is one of the most spectacular that we've found anywhere in our galaxy. Now, we know a lot of what we do at the moment about how stars are formed just by studying the Eagle Nebula. Let's just put things into perspective here. The Eagle Nebula is about 70 light-years by 55 light-years in size, and it rests approximately 7,000 light-years away from us. So this particular cloud of gas is absolutely immense in its size. It's huge. It's spectacularly, brilliantly vast. With our current technology, it would probably take us 140, 280 years to get from one side of it to the other. So yeah, it's pretty enormous. Now, what you're looking at the moment, these pillar-like structures, we actually call the pillars of creation. They are part of this vast stellar foundry. Now, nebula are basically the leftover remnants of the birth of the universe. They're pockets of hydrogen, gas, and dust. Now, in this picture here, you can actually see stars being born. They're like the little purple stars that you can see, purple in colour in this picture. Now, those stars are actually in the early part of their lives. They're just forming. At the moment, they're probably as large as our own solar system, They're still condensing and collapsing in on themselves, and some of them may already be millions of years old. Now, I mentioned earlier Jupiter being a sort of akin to a failed brown dwarf, and that's kind of misleading. Because planets have a different formation process to stars. Now, Jupiter was formed from the disk of matter that forms around newly birthed stars, and it's from this disk of matter that planets and other bodies in our solar system formed. Now, Jupiter would probably need to have been about 13 to 14 times bigger than it is at the moment to form a star of any sort, even if it would only be a brown dwarf. So, brown dwarfs would be more accurately described as failed stars, but I know that Jupiter has been referenced a lot as a failed star because it is basically a giant ball of gas, mostly hydrogen. But yeah, people call it a failed star, and it's kind of misleading calling it that. But the process is similar to a gas giant. It's just that a star it basically has far more mass, which allows gravity to act upon it, causing it to collapse in on itself, causing the fusion of hydrogen to create helium, which sets off the reaction which gives birth to a star. Now, the pressures in Jupiter, when you start getting below the surface and deeper into the gas giant, become vast. The pressures become massive, but they're not enough to cause the fusion that we see in our own star. So, yeah. Anyway, very, very easy, very simple explanation there. If you want to do some more research on the birth of stars, please, by all means, go in and have a look. We have several types of stars, from our sort of star to red giants. There are even some blue stars out there that you could take a look at and have been seen with the likes of Hubble Space Telescope. Now, in my next video, what I'd like to go through is the formation of our solar systems, which will kind of tie in as well to the formation of stars, because the way a star forms, it leaves a disk of matter and hot dense gases that are used in the creation of planets and asteroids, etc. So, yeah, that's going to be really interesting, and I hope to see you all there.